Welcome everybody to this bi-monthly demo session, which we organize every 2 months as part of the DiSSCo Transition projects, as part of task 3.1 to show the progress with developing the core DiSSCo infrastructure. As I already said, we record these sessions to make them available on our DiSSCo blog, and yeah, we give these sessions to give an overview and demonstrate the progress with the development for all our stakeholders who are interested in the technical development. To give an update, but also to give you the opportunity to give feedback to the development, so that we can adjust the developments to your needs. So welcome everybody. Can you share the slides?
Yeah.
So the development team at Naturalis is basically three people. It's Sam, Sue, and Tom. Tom is on holiday today, but he recorded an overview of what he has been done the last 2 months, so we can also go over that quickly. Next slides. Next slides. So what we want to present today is an update on the openDS specimen data model, which is currently under review. I hope that you all have received a message to review that and give comments on the implementation of the data model, on handle storage improvements, and an update on the development of the DiSSCover annotation interface. We also will shortly present what looking forward, so what we aim to do in the upcoming 2 months, and we hope that there is some time left for discussion. I will now give the floor to Sam as our lead developer, so he will start with the openDS data model.
Yeah, thanks, Wouter. Yeah, I'm happy for everybody that's here. We know that it's still more or less holiday time, and that probably a lot of people are already on the move towards Japan for TED Week next week. So we appreciate you being here and getting this update. Yeah, quickly we've started with the demo. So I said to give some insights into what we're doing for the deliverable 3.1, which is part of the DiSSCo Transition project. Get some overview so that we're not suddenly dropping this deliverable. No, the idea is that to keep you in the loop, to show what we're doing, so that you can actually see the progress that we're making, and can give feedback and questions on what we're doing. So mostly are on DiSSCo Transition project. We also mentioned some Tetris stuff because it's a bit related, and some of our developers are working on Tetris. So topics are: what have we done in the past 2 months? Let's say the past 8 weeks. What are we planning to do? And then some room for discussions, is what you mentioned. We will record and share the recording on our blog post. For the ones that are here the first time, I will show this slide just to give a bit of overview. We see DiSSCo as a platform where we have data providers on the one side providing all kinds of data, mainly CMSs, but they could also be digitization suites. Data consumers like data aggregators, but also things from DiSSCo could flow back into the CMS. And then we have DiSSCo, where we have human agents and machine agents together working on the specimen data, extending it. So we're collecting and harmonizing all this data to openDS, which we'll talk more on a bit. We'll mint PIDs for these specimen, we'll version it. You can start annotating the data, so machine agents and human agents can together start annotating data. You can extend the data, link it to other infrastructures, other data storages in other data infrastructures for, let's say, DNA, georeferencing, taxonomic literature. So linking all this data, and of course we expose this data so that other platforms, such as the citizen science platforms, can also start using this data, and together we want to grow this specimen information into this huge digital extended specimen where we have all these connections and all this additional data, and we have collectively created this full specimen record. This is the part we're focusing on. We're trying to get this core infrastructure in place so that everybody can start working on the specimen, get the PIDs in place, and we will have a couple of machines that we're piloting that they want to have there. And we have DiSSCover, which is more of a human-facing platform where humans can interact with the data. So what's new? So the biggest topic that we have is open digital specimen. So the open digital specimen is under review at the moment. We have extended the review until after TED Week. We hope to get some more people interested during TED Week as well to promote it there. And you can have a look at it on dev.terms.disco.tech, where most of the documentation is. I can open it. Hopefully most have seen this already. It has some explanation, and then we have all is it, I think, 7 digital objects, and the biggest one is obviously the digital specimen. So the digital specimen, we have proposed a lot of terms for this, some introduction, and then we have a lot of terms. We do know that it's quite a lot to take in. So also feel free to just send emails or ask questions, or anything is welcome. But this explains, for example, what we mean with ODS citation page. You go there, you see the term, you see the label. We indicate that it's a string that is not required and it belongs to the citation class. So there's a lot of information here. The guide is a kind of quick reference guide, which more or less shows it per class. So if I look at citation, I will see that citation has these fields, and these fields are, then I know a bit of the structure from how it's how the whole model fits together. And then in resources, we have a bit more additional resources. So there's this really big class diagram with all the connections. But we also have a more of an entity relationship diagram where you can see more on the digital specimen and see that it has an one-to-many relationship with material entity, or that it has a one-to-many relationships with identification. So this is more of an entity relationship diagram. As I said, feel free to give feedback, to ask questions. I will also dig into it a little bit in this demo. Yeah, there we go. We'll look a bit at the data model changes that we did throughout the infrastructure. So we're already a bit moving ahead in that the version that we now submitted for review, we also implemented in our infrastructure. So most of the changes have already been done. So yeah, of course, we need another iteration to get all the review comments in, but at least we can show some examples on how the data now looks. I will talk a bit about the improvement of the handle storage. We've improved quite a lot on that part. We have updated and are still working on updating the machine annotation documentation. We know that there are people interested in adding machine annotation service to DiSSCo, and we want to have documentation ready and probably some examples on how we can do it. So this is something that we're working on as well. And we will also continue to work on this part. We did some first tests to integrate with the Naturalis observability stack. They've created a platform which suits us quite well. Something that we need to do for this is create a static egress IP so that all our traffic going outward has the same IP address, so that we can get whitelisted at APIs of other infrastructures. So this is also something we actually needed for the communication with Minnet, and we are expecting that this is a requirement for other infrastructures as well to communicate with them. So we put it in place. And the Naturalis observability stack also gives us the possibility to create service uptime monitoring pages. So that's a bit on that side. We have improved the mass support, so we're now supporting secrets as well in the deployment process. The secrets still need to be provided to us by a secure way, but then we can inject those secrets into the machine annotation service. So that's a good step there as well. Improvements in front-end code. Tom will talk a bit more on that part. And yeah, for the Tetris Marketplace, we had a good milestone where there was a workshop on the Tetris Marketplace, and the first prototype is now has now been released. So we'll keep iterating on this Tetris Marketplace, but it was also a good milestone to have this first prototype standing there. Yeah, let's go a bit more in depth. So how is this the thing with openDS structured? And this is something I wanted to mention a bit earlier, I think in the previous demo as well, but got a bit crowded there. But why do we have this structure where we have schemas and in terms of DiSSCo.tech, and how is it structured? So for us, we started seeing that we had more and more applications and resources needing to know how our data model looks like. And we had information in a couple different places. And that's difficult to manage, because if you make a change in one place, you also need to make the change in another place and in another place as well. And then you have suddenly at 5 or 6 different places that you all need to synchronize and all need to keep in check. So we wanted to do this differently. So we decided on using GitHub as a platform to discuss and request changes in the data model. So this is basically the platform where people can go in, start creating issues. It's also the place where which we use now for the reviews. When we have agreement on a change in the data model, we can accept this agreement, and this agreement will immediately trigger and be exposed to schemas.DiSSCo.tech. So this is basically the home of our data model, schema.DiSSCo.tech. They're in JSON schemas, which for humans isn't the best way to read these things. It's a bit cryptic. So based on the schema.tech, we have generated the terms.DiSSCo.tech, which is basically the human readable version of our data models. But we not only have created this page, we also generate our code. Part of our code is generated based on the schema.DiSSCo.tech. Part of our documentation, or basically or documentation regarding data models, also for OpenAPI, so descriptions of our API, is generated based on schemas.DiSSCo.tech. Or FDL registry, so the registry describing how our objects look like, our digital objects, will point to schemas.DiSSCo.tech. So we basically created a central place, this single source of truth about our data models. And yeah, this is really important, because external applications can also start using schemas.DiSSCo.tech to generate a code to know how our models look like. Machines can start using it either through the FDL registry or directly to schemas.DiSSCo.tech. And we always know that that's the up-to-date version of our schemas. So that's a really good step, that we centralized all information of the data models on that particular place. And then just a bit more on openDS, because people indicated that they find this image helpful as well. So these are a bit more, it's a bit of the extended version of the entity relationship diagram. And this indicates that we have the digital specimen here as center. And this digital specimen has relationships to other objects. And those relationships could either just be that it's a single object, but if it's called has something, then it indicates that this digital specimen can have multiple of this other object, basically 0 or multiple, to be precise. So in the case of a digital specimen, this digital specimen can have 0 or more events. And these events can have 0 or more locations. But this location can have only one georeference and one geological context. So that's how you can walk through the data model. The digital specimen can have 1 or more geometric age. It can have 1 or more or 0 or more assertions. So assertion saying a certain measurement or additional information about the specimen. It can have 0 or more entity relationships. And then we go here to entity relationships. It can only have 1 tombstone metadata, on which I will tell a bit more in one of the next slides. but it can have one of 0 or more agents. And so that's how you can walk through the data model and see how the relationships and how it's tied together. And what you will notice is that, for example, identifier has 3 arrows pointing to this identifier. So there are 3 objects within this digital specimen that are using the identifier object. One is the digital specimen. So the digital specimen can have multiple identifiers. We know that there are often multiple, sometimes local identifiers, more global identifiers, sometimes specific catalog numbers. So we know that there could be 4, 5, 6, or even more identifiers for the same specimen. So that's why we have this 0 or more identifiers. So then we can have 6 identifier objects, all with information about identifiers. But the digital specimen can also have 0 or more material entities, which is basically, let's say if I have a big rock and I want to describe the rock itself as well, but on the rock is a mineral, I want to describe the mineral as well, then I can describe the mineral as a material entity, which is part of the bigger specimen. So it's kind of a part of this specimen. And this material entity can also have 0 or more identifiers. So if it has a specific own identifier, we can also indicate it. And then we see that there's another line coming from agent, and agents can also have 0 or more identifiers. So if we have multiple identifiers for an agent, let's say it's a human agent, we can have an ORCID and a Wikidata identifier, and maybe you have additional identifiers for this particular agent as well. We can all add them to the agent. And you see that agent in particular is a very interesting object because we have a lot of relationships going to agent. That's because we've tried to make one generic agent object describing a person or a machine agent. So a machine application could also be an agent. And we use it in most of our data models. And you see that, for example, if we want to know who created the entity relationship, we point to the agent object. And here in the agent object, we can enclose information about a particular agent who created this relationship. The same is for assertion. So a particular assertion, let's say somebody took a measurement and you want to capture who took that specific measurement. We can add that information here and include his ORCID identifiers, his Wikidata identifiers, all the other things. We can include it in the agent object. So this becomes a really powerful object. And this is a bit of a way to walk through this whole data model, get some understanding on how everything is connected. We know it's quite a lot. It's quite, but we also want to capture a lot of information, so that makes it that it's so broad. But we do try to reuse as much of these objects as possible, of identifier objects, agent objects, citations. Yeah, and as I said, let us know if you have any questions or comments. Yeah, well, I said I would want to look at tombstoning, and tombstoning might be a new topic for a lot of people. So tombstoning, you can see it as a replacement for deleting. So normally you have the create, read, update, delete actions on an object, but instead of deleting, we'll tombstone an object, and that has reasons. We don't want data to disappear. So for objects, for digital specimen, we'll mint DOIs, and these DOIs will start their own lives. They will go into the CMSs, back into the collection management systems. They will also be in publications. They might be on websites, and the information, what's behind that DOI, if I have a reference of a DOI in a publication, and I select the DOI and then come to a completely blank page because all information is gone, then the value of the DOI is completely gone. So we want to keep that information, but instead of deleting the object, because of course an accident can happen, you suddenly split the object and the old object is no longer there. So the stone and the mineral, you separated them and you created 2 separate digital objects for it. They both got their own persistent identifiers, their own DOIs, and the old DOI is no longer relevant. So normally you would delete it. We say we don't delete it, but we tombstone it, which means that the information is still there, And when you go through the DOI, you will still see the information, but will indicate that this is a tombstone record, that it's no longer an active record. And within that record, we might want to reference to the newly created digital object. So we split this digital object into 2 digital objects. And now within this tombstone record, we provide information. This record that you are looking at has actually been split, and these are the resulting DOIs. So we capture that information in the tombstone record. Another plus sign is that the tombstoning actually makes it reversible. We don't delete it. If you tombstone the record, you said, well, I misclicked, I clicked the wrong one, or I pushed the wrong button and now it's tombstoned. That's okay, we can untombstone it, let's say. We'll still keep your actions there, so we'll have, we know that it's been tombstoned and it has been made active again. But yeah, mistakes can be made, and the data won't be lost. To do this, each digital object now has a status, which is either draft, active, or tombstone. And we introduced a tombstone metadata object. Here's the link to the schema on schemas.dissco.tech. And this captures the date, an additional text, why it has been tombstoned, the agent that's tombstoned the object, and links to any related PIDs and what that link is. This fits a lot better with the DOI concept, and we'll still have all the information of the original of the tombstoned object in our systems, so we can display it. You can have a look at it, and if we show it on DiSSCover, we'll put a big red marker there saying this is, be careful, this is a tombstone record, it's no longer active. And we'll also put it in the data at the top. So these things are at the top, so that people actually know they're looking at the tombstone record, but all the information is still there. And if the DOI has been used in the publication, you can still go back and see why that specimen has been tombstoned, and if you now should use any other PID for the specific digital object. Yeah, and implemented, I quickly go over this part because it's just to show that we now have an example of a digital specimen in a new format. So you'll see that all these things has identification, is now an array, and in that array is this particular identification, which has a taxon identification, which is also an array. And then you see here the whole taxon identification. Of course, it has been matched to the category of life, the event, and entity relationships. So in this case, it belongs to an organization, and the organization has an organization ID, which is the ROR. And this relationship has been added by an application, which is our DiSSCo translator service. And this DiSSCo translator service will also get a handle, so that you can find additional information about the translator service, so that you know which version created this. Let's see, we have another one, and this has been by the DiSSCo name usage search. So it's the category of life identifier. So this application matched the specimen against the category of life, and added a relationship to a category of life identifier. So now this is how the entity relationships work, but it's just a bit different than how the previous data model. Annotation example. You have an annotation here. It also has all the properties, the body. So and the creator again uses the same agent object with the same kind of properties in there, the same kind of terms. That's nice as well. We have the source system where we now make heavy use of schema. So we use the schema terms here instead of our own terms to connect better with schema. And there we have schema creator, but this is an agent object from the generic agent object that we have. Machine annotation service where we have the target digital object filters. We tweak this as well a little bit. Have some different terms in here, And the one that's changed the most is actually the create delete tombstone event, which I have here because we don't expose it to an API yet, which now is based on the prof ontology, and we have prof activity and then the activity, which is associated with particular agents, and these agents are in the ODS prof agent as agent, and the entity. So it's now all these changes have been worked through the whole system and are now active on our development setup where we are testing them and implementing them further. Good. One more topic before we switch to the front end with Tom: improvement in the handle storage. So as you know, all digital objects in DiSSCo get a persistent identifier, a PID. Digital specimen and digital media get the DOI, which we meant with DataSite. There are other resources. We go into a lot more depth on this part, but that's a general gist. In our previous setup, we used a relational database, a Postgres database, to store these records. So on the bottom, you see a bit of the flow. We have a processing service. So let's say we get a digital specimen in, then we'll create, update, or create a new handle in our handle storage, and this handle storage will be exposed to the PID API, but also to a local handle server and the global handle server. And especially the limitations in the local handle server were the reason why we opted for a relational database. But we knew that we're going to meet a lot of handles. For example, if we get annotations and we get millions of objects in, we will get maybe millions or tens of millions of annotations, and we'll be hitting the limits of a relational database for all these handles. So we knew that eventually, probably not in the first year or years, but eventually we'll start hitting a bottleneck with the way we've set up this handle storage. But we weren't able to change this ourselves because we were depending on CNRI and the local handle server to create an additional change in their code as well. So we had discussions about these limitations with CNRI and requested them to support additional storage options for the local handle server. And yeah, I think they agree with us, and we're in the process of increasing the options for handle storage themselves as well. So we're now probably the first tester for a different kind of setup where we use a document store, MongoDB, to store our handle records, which is yeah, we're a bit trailblazing there. I think CNMI also indicates that DiSSCo will be one of the first one will start massively creating handles in DOI. So we're doing it a lot more than, or we will be doing it a lot more than is currently be done. And that means that the solutions around handles and DOIs will need to scale as well. They also need to make a step. I think for the handles, local handle server, this is one of those steps that the whole infrastructure, the whole broader infrastructure, needs to make to support a larger quantity of handle creations. So it's better scalable. We still have similar performance, so we're quite happy with it. But the searches will be faster, and it's easier for development as well. Before we had this database table, and we had like 22 rows just for the single handle with all the things described. And now we have one object, and in that object we have all the information about the handle. So we no longer need to combine all these 22 different rows, but we have this one object, and that works quite well for us. So that's the part that Sue has been working hard on, and yeah, it looks really well. So we'll also provide this feedback back to CNRI so that they can use it for the broader community. Next one is front-end improvement, and Tom was very kind to provide us with the video.
I don't hear anything.
There's no sound, Sam.
Just to check, do you have any sound for the video?
No.
Okay. Wait, it looks like it might be as simple as.
So when the API gives
Yeah.
an error,
Looking. Yes.
we now have handlers, which also provides indications to the user what went wrong and what the user can do to resolve this, or mostly try again to do the fetch request. There's also some missing features because we started with like a base application, so like a really bland application, and practically rebuilt everything. There are some missing features we did not yet get to, which are the digital media page and the profile page. The annotations, which are not implemented yet, but we're currently working on locally. The machine annotation services are also part of that, and the tour functionality. So our new /refactor version is available at dev.DiSSCo.tech, which is our development environment. So you can test out and see the refactored version and mind these missing features. But the old version, so the original, is still available at sandbox.DiSSCo.tech and still contains all the features we originally have. In the coming months, we'll complete the refactoring process, and the missing features will also be integrated in the new version. So let's do a quick demo to showcase what is changed. So I got 3 versions over here. This is my local version. This is the dev.DiSSCo.tech version, which you can also access. And this is the sandbox.DiSSCo.tech. So this is our original version, the old one. This is the new one, and this also, but this is my local work version. So for example, we can grab the dev version. And if you look from the start, it doesn't seem to have changed much. And this is what I meant by we mostly worked on the backgrounds, improving the code, improving the structure, naming conventions, that kind of stuff. We did do some enhancements, like if I move between tabs, you can see the spacing and aligning of elements is much more cleaner in this version. Also, the stuff is a bit bigger, like the elements are bigger, and the text used now a new font, and some styles were improved upon the styling guide we made for DiSSCover, just to be more consistent. So the consistency we wanted, the rules I showed you, they also apply a bit to the visual representation of the components you see. So this is the home page. Of course, some things are also missing here, like the icons, for example, which they will for surely return. And so there are like other features like the tour I mentioned, which are not working yet, but they will return in the coming time. We continue refactoring. So some new stuff are things that really changed. I mentioned the taxonomy filter, which is really neat now. In the previous version, you went from top level, so you started with Animalia and then go down to film and continue to class, and it would crash sometimes, like you see. So that was not the best system. So we spent, I think, it was for sure 3 weeks we spent on the new taxonomy filter, which is now really a tree structure. So if I have 3 kingdoms at the moment, which are duplicates, but don't mind that. So if I select Animalia, it will open this branch of Animalia and display the names we now have of the films. And if I select the film, it will go to class will go to order will go to family to genus, and finally genus to species level. So you're gonna go all the way down. And the neat feature is you can still select like other stuff as well. If it doesn't break. So it might is still in development. If I deselect the filament, it will go back and you can just select new ones. You also still have the species search. So if I search for Megacolex, it will dig down through the tree and search for the species. So this species is inside all these different levels. So I think it's a really neat feature for filtering, and it makes filtering easier than the original filter we had. So I mentioned the compare. So you can now compare like up to 10, and the compare now looks like this. It's more horizontal, but the properties will remain on the left. So you can easily compare multiple specimens, and even select additional ones if you forgot some. So I select one more, and it will add it to there as well. So that's what we changed. Yeah, of course the search fields also changed a bit. Now all the values are still in there, like in the old version. If you selected a country, for example, Denmark, the other ones would disappear. It was intended, but not really user-friendly. So the new version we changed that. So if you select Indonesia, the rest will remain, and you can also just search for Austria, for example, and continue your filtering process by selecting multiple filters. And this applies to all the filters. Finally, with the specimen, the ID card's mostly the same, but as you can see, text is a bit smaller over here. It's just a bit more nicely aligned and arranged to make it more professional. The specimen page itself, we're still working on it a bit. As you can see, the content's a bit empty, but the things are getting there. It's also a bit more neatly organized. Like, see, it's a bit, yeah, not as a bit more quiet, I would say. Like, and currently in your local environment, we're working on the annotations. So this is a kind of look ahead of what we're doing. So the annotations are upcoming. And one neat feature we also introduced, what I mentioned in PowerPoint, is loading screens. So if you look really quick, if you refresh the page, it will just say loading digital specimen. And if the fetch request takes a lot of time to complete, it will display the message and then give an indication to the user, oh, you have to wait a bit. And this also applies to the table you saw and the specimen card. So it will briefly load while you select one, because these are all requests to the API, and those take some milliseconds of time. So that's basically how far we are now with the refactoring process. So upcoming are the annotations, and of course the other stuff like the digital media page and profile, machine annotation services. They will also all be re-added in the future. Yeah, and that's, I think, it for today. So in the next demo we'll probably give another overview of what we have been working on, and hopefully by then we can also move towards a complete version, to a complete refactored version, which is available at our dev environment. So until then, we'll continue developing, and well, see you next time. Thanks for listening.
Yeah, thanks, Tom. Yeah, let's move onward to seeing. Having a look forward. As Tom mentioned, we want to incorporate the review feedback and move the openDS to officially the first final version, so 1.0 version, and publish that on our platforms as well. Which also means that we need to finalize the implementation of openDS in the infrastructure. So that's part of what Tom is showing. So make sure that all the information of digital specimen is there in the page, that all the pages work, and that in the back end also all the APIs are aligned with the openDS 1.0 version. We have, as Tom showed, we have made a lot of small but really good front-end code improvements to make sure that we have a good sustainable platform on which we can build further in the future and add additional functionalities. We'll be producing annotations when data gets created or updated through a source system. So that also the first ingestion will trigger an annotation. So basically the concept is that we will get a DOI, and then the first adding of all this information is kind of like an automatically accepted annotation. So the annotation will say, well, we want to add all this specimen information, and then the annotation is accepted and it will be put into the digital specimen. And also for updates, we'll do the same thing for the digital objects that come from the source system. So that's a digital specimen and digital media. We'll further document how you can supply data and metadata, and we'll help some of our machine annotation providers to integrate with the DiSSCo infrastructure. We know there's a task that Jonas is also here and Schickenberg are working on for DiSSCo Transition project milestone 16. We want to have that ready and be able to help them. We also got questions from other partners on how they can integrate and test the machine annotation service in DiSSCo infrastructure as well. So that's a good sign. So we want to put some effort in that as well. Yeah, move towards the observability stack. I'm hoping to test it in a couple of weeks. And have the whole chain running, so we have some monitoring on the systems when we actually go into production. Tombstone specimen records, they improve login and registration with ORGID. We have talked with the RNet on how we can improve it, because we basically require an ORGID to identify an agent working on the system. Of course, we'll extensively test because we're slowly moving towards our MVP product. So I'll do more testing and checking if everything is ready. We'll have a lot of small things that we need to clean up nicely. Work continues on the vocabulary server, the status marketplace, and I hope it's readable. Otherwise, I can move this a bit to the front. We'll gather requirements and priorities for after the MVP, which will be a workshop. And the work packet 2 will be organizing on the 30th of October. And with that, one last thing is to have a look at DiSSCo at Tedwick. I just want to mention that we have a couple sessions at Tedwick that we will be active in. So Lawrence Livermore and some more people from MHM, the National History Museum in London, will do a workshop on Latimer Core, which is part of DiSSCo Transition Work Package 4. And to get more information and display more how Latimer Core can be used to describe collections. Then Wouter will do one on DOIs. The future of referencing specimen is near. Cite the digital specimen DOI on our DOI infrastructure. Tom will again show part of our DiSSCover system and the potential of doing fair digital object annotations. So manual annotations through DiSSCover. And Elspeth Hastings will talk about completing the completeness measure, the MID specification, in which we're also active as DiSSCo. And another symposium that might be interesting is the emergence of integrated public collection services, today's digital extended specimen experiences, which is also part of what we're working on. So if you go to Tedwick, please have a look at these sessions, get more information on DiSSCo. Additional resources, I will leave that in. So if you use the presentation, you can have a quick links to our resources. And then for discussion, and the last mention is that we still have the openDS review ongoing. So feel free to have a look at it until September the 10th. Are there any questions? Oh, I can close this one. Share. Okay, yeah, just to mention, Wouter and Chief will be representing DiSSCo, so they will be in person in Okinawa. So feel free to tackle them there if you're going. I will be attending virtually, so you can also send me an email or a message if you have any questions regarding DiSSCo. The next session, maybe I can show slides again. Next session we have already planned on Wednesday, the 23rd of October, again at 11. So that's eight weeks from now, more or less 2 months. Then we'll do the next session, and we're hoping that we then can present lots of things that we're now applying, so that we can present the whole openDS 1.0, the first version of that we have. Tom has continued building on the front end, so we can show DiSSCover, and we're really close to an MVP on that part. So I really hope to see you there. And in the meantime, if anything comes up, feel free to contact us, and we'll get in touch.
Thanks, Sam. We still have about 10 minutes left. So if there are any questions, or if you are missing any functionalities, or if there's something that you would like to know a little bit more of, please. The floor is yours now.
I have a question. Sorry.
Yes,
There's
Frank.
another meeting. In the JSON data, what does the acronym ODS and OA stand for? That's for schemas, but which schemas?
Yeah, thanks for the question. Yeah, the prefixes that we use point to the vocabularies that we use for the ontologies. I'm now sharing. Let's see if I can share, and I can actually show you one. So let's say for agent, we have here agent name. And if we go to agent name, you will see that we actually point for the term ERI to schema.org/name. And the schema.org, we basically borrowed this name term from the schema ontology, and they are, say that, responsible for this specific term. So we reuse the term. And this is a kind of concept coming from the linked data community to create, hoping I'm saying it right, but to create this kind of linked data objects through the shared usage of these terms. And we will use it as well to create JSON linked data, JSON LD. I don't have an example at the moment, but this is quite a good page to get some more information on it. JSON LD, so it's JSON for linked data. JSON is what we use to store objects in a JavaScript object notation. And what this provides is basically some additional information about the terms that you use in your JSON. So each term will be have a link to the term and then the concept of the term. Is that a bit clear?
Yes, thank you. Is it possible to have them? You probably send this in LR meetings, but to have the web page with the global vocabulary, summarizing the vocabulary. Is it possible to send it to the community? Probably you know this already, but as I missed the earlier meetings, I don't have this page.
Sorry, to
send the first page, you shown the page with a list of terms specific to DiSSCo.
Yeah, this one.
Yeah, this one. Yes, I will copy the URL. Sorry.
Yeah, no, and it should be in the public review as well that we sent around.
Okay.
Yeah. So
thank you.
yeah, it's also in there. So if you have the PDF or the message with the announcement of the public review, we also point to yeah, here it is. We also point to dev.terms.disco.tech, where we have all this information in, and of course for the digital specimen, for example, we point a lot to the Darwin core terms. You also see here that yeah, let's say basis of record will point to the namespace of Darwin core for the basis of record, so that you actually go to this space, and then you'll see here the definition, some notes, examples, equivalences, and the decisions about the term, so that you have each term can be traced when the decision was made and why the term is there and what you can expect to have in that term. So that connects it to the broader data standards landscape. Yeah.
Yeah, thank you. Very useful. Thank you.
Okay.
Any more questions?
Maybe I can ask a question about the agent. Is the agent always meant to be a person, or can it also be an institution or organization?
It's a good question. I would say agent can also be an institution or organization, or that it's broader. I don't think we have examples of it yet where we have an institution there, but in essence, I think it would still fit all the requirements we have for agent. Yeah, so it should have a unique identifier. We often for organizations use RR, as the identifier for an organization, a name, and then you can add additional information as the specific role it has in that context, whether it's a collector identifier. But yeah, it should be possible. We don't use it in that sense yet, but it's generic enough to encompass it as well. Yeah.
Thank you, Stefan. More questions? Dagmar?
I have a question. How, where in the data model is the link to the storage of the physical material?
Okay, do you mean to the actual room and sorry?
Yes, to the physical specimen and its storage at an organization and also in a room, in a cupboard or whatever. Mainly the institution.
Yeah. So which institution? That's something we add in the data. Then we use the RR Wikidata identifier of the institution to uniquely identify the institution, and we have the name in there as well. What we don't store, because we don't think it's particularly relevant for scientists, is on which shelf or in which room, because that's something that will stay in the collection management system itself from that institution.
Mm-hmm.
So that's not something we store within DiSSCo.
Yeah, we see
And
that.
to have the link to ELWIS system, you need at least the institution.
Yeah, the institution we store. So you know the catalog number for the specimen, you know the institution that is hosting it. So that is what we store, but we do not store in which building on which shelf the object is stored.
Yes, and where in the data model you have shown a nice entity relation diagram, and where is the place there?
That is in the digital specimen itself as identifiers, relationship with the identifiers. And we store that information
Okay.
also in the PIT records in the DOI itself.
Okay. Mm-hmm.
So you can find that information even if you only have the DOI without having to go to the to full data.
Mm-hmm. Okay. Mm-hmm.
So yeah, as Sam explained, that information we see as management information, asset management information, and not particularly relevant for science, but there may also be security issues with showing that kind of information. If you have objects that are very valuable, you probably don't want to publicly show exactly where that is stored.
Thanks.
Any other questions? Okay, if there are no further questions, I think we can end this meeting. Thanks again for participating, and yeah, if you have any questions afterwards, feel free to ask them over email or Slack. And if you have any further comments on the openDS data models, please add them to our GitHub. Okay, thank you.